They say that in war, the most dangerous weapon is the one you never see coming. And as American forces pushed deeper into Europe in late 1944, they began hearing scattered battlefield rumors, accounts from infantrymen, rangers, and paratroopers about a strange new German rifle appearing in the east and now trickling into the west. A weapon with a profile unlike anything the Allies had encountered. Something shorter than the Carabiner 98K, but far more controllable than the MP40. A gun that allowed German troops to fire at longer range than submachine guns, yet faster than any standard rifle, delivering a storm of bullets from positions where no one expected it. Soldiers called it that new German machine rifle, or the Sturmgewehr, and although very few Americans had actually seen one up close, the weapon was already redefining small arms combat on the Eastern Front. But nothing prepared the American engineers for what they found when they finally got their hands on a captured example. The moment the rifle reached U.S. ordnance testing grounds, its metal still bearing dust from the ruined towns it traveled through, the first reaction was disbelief. Some examiners reportedly muttered that it shouldn't even exist yet, because no army in the world was supposed to field something this modern. To them, the weapon looked like it had skipped an entire generation of small arms evolution, and the more they studied it, the more that shock deepened. This is the story of how American engineers examined the German StG-44, the world's first mass-produced assault rifle, and realized, almost with a sense of dread, that Germany had been fighting with a weapon decades ahead of its time. But to understand why this discovery hit so hard, and why the StG-44 was such a psychological blow, we must step back into the war's earliest years, long before the weapon earned the name that would define it, Sturmgewehr, assault rifle. When World War II began, every major power entered the conflict equipped with rifles rooted in World War I doctrine, long, powerful bolt-action weapons firing full-power cartridges designed for engagements at hundreds of meters. The U.S. had the M1 Garand, groundbreaking in its semi-automatic capability, but still using the .30-06 cartridge, a round nearly identical in concept to the German 7.92 by 57 millimeters. Britain had the Lee Enfield, Japan the Arisaka, the Soviet Union the Mosin Nagant. These rifles were accurate, reliable, and lethal at long range. Yet battles were no longer unfolding like 1914 trench warfare. WWII's engagements were faster, more chaotic, often at 100 to 300 meters, distances where full-power rifles became harder to handle, slower to shoot, and excessive in recoil. Germany's high command understood this too, but the need for a new weapon grew even more urgent as reports began arriving from the Eastern Front. There, Soviet troops armed with the SVT-40 semi-automatic rifle, and especially the PPSH-41 submachine gun, were overwhelming German infantry at closer ranges with sheer volume of fire. German soldiers were forced into a terrible psychological disadvantage. They carried rifles optimized for long-range marksmanship, but they were often fighting in forests, ruined cities, and close-quarter ambushes where the PPSH's drum magazine and high rate of fire dominated. German infantrymen repeatedly reported feeling outgunned, not in terms of power, but in terms of adaptability. They began demanding a rifle that bridged the gap between long-range precision and close-range firepower. Something with enough reach to outperform submachine guns, but controllable enough to fire quickly without the brutal recoil of a full-power rifle. The answer emerged not from the German high command, but from engineers at Henkel and Walther, who began experimenting with a completely different idea, a rifle chamber for a new, intermediate cartridge. Instead of the powerful 7.92 by 57 millimeters Mauser, they built weapons around the experimental 7.92 by 33 millimeters Kurz, literally short cartridge. It was lighter, easier to control, and allowed soldiers to carry more ammunition without added burden. At first, Hitler himself rejected the project, believing new rifles would disrupt logistics and preferring that resources focus on existing weapons. For a time, the gun developers had to disguise their work under misleading nomenclature, labeling prototypes as MP-43, Massenet Pistol 43, even though the weapon was not a submachine gun at all. But on the Eastern Front, where survival mattered more than bureaucratic approval, frontline reports told a different story. Test units equipped with early versions of the weapon sent back glowing feedback. They wrote that they could finally match Soviet firepower. They updated logs saying the weapon allowed them to hold ground against overwhelming odds. And above all, they emphasized that this new rifle, whatever its name, fundamentally increased the lethality and confidence of German squads. In a war where psychology, fear, morale, perception of advantage played as important a role as hardware, this mattered immensely. When Hitler finally inspected the weapon in person and saw its battlefield results, he approved mass production and gave it a new name, Sturmgewehr 44, assault rifle. It was a name chosen for propaganda impact, but destined to reshape global small arms development. By late 1944, the StG 44 began appearing more frequently on the Western Front. American troops encountering German units in towns, forests, and nighttime engagements occasionally came under fire from bursts they couldn't immediately categorize. It wasn't the slow crack of a bolt-action rifle, nor the low-range chatter of an MP40. It was something in between, controlled, accurate, and unnervingly modern. When captured rifles were sent to American ordnance examiners, they understood that this was no rumor. The weapon was real, and it was revolutionary. Upon receiving their first intact examples, U.S. engineers immediately noticed the rifle's mixed construction. Machined steel in the critical areas combined with extensive use of stamped metal components. This wasn't a flaw. It was a design philosophy the Americans were only beginning to explore in their own projects. Stamping meant faster production, lower cost, and fewer machining hours, all critical for wartime output. Yet the Germans had managed to apply stamping to a rifle that still felt robust in the hands. Against the backdrop of late-war Germany, where resources were dwindling, this level of manufacturing efficiency left American examiners quietly impressed. Then came the firing tests. On the range, the StG 44 revealed its true significance. The intermediate cartridge produced manageable recoil, allowing controlled bursts, something the Americans had never seen in a standard infantry rifle. The engineers noted the weapon's surprising stability, its ability to deliver rapid shots at combat-relevant distances, and its impressive balance of controllability and firepower. After decades of doctrine built around long-range cartridges, the Americans were suddenly observing a weapon deliberately built for the realities of mid-range infantry combat. More than one examiner wrote variations of the same sentiment in their technical notes, that the StG 44 represented an entirely new class of infantry weapon, a weapon category no other nation had fielded, a concept that would later inspire not just post-war research, but entire families of rifles around the world. Yet understanding the StG 44 required understanding conditions that created it, the desperation of the Eastern Front, the evolving nature of urban and forest combat, and the psychological warfare embedded in infantry engagements. For soldiers under fire, the weapon you held influenced not only your capability, but your confidence, your perception of survival, and your sense of power in the chaos of battle. And on those cold, smoke-filled streets in 1945, those who carried the StG 44 often felt they finally had something that matched the brutal efficiency of Soviet firepower. But for the Americans who examined it, there was another emotion, one they rarely recorded in official documents, but sometimes hinted at between the lines. A quiet recognition that if Germany had fielded this weapon earlier and in larger numbers, the battlefield calculus might have been very different. The StG 44 wasn't just a weapon. It was a glimpse into an alternate trajectory of warfare, a sign that the future had arrived early, forged in steel by a nation racing against time. And as American engineers continued to disassemble, analyze, and test the rifle piece by piece, they began uncovering design decisions so forward-thinking that they raised an unsettling question. How did Germany, under immense pressure and diminishing resources, manage to build something this advanced? The answer, as they would discover, lay not only in engineering, but in psychology, necessity, and a war that demanded a new kind of weapon. When American engineers began their formal evaluation of the captured StG 44 at Aberdeen Proving Ground, they approached it with the same methodology applied to every foreign weapon that passed through those gates. But almost immediately, it became clear that this rifle did not belong to the same category as the others. It wasn't an upgraded submachine gun. It wasn't a lighter rifle. It was something fundamentally new, something that demanded the examiners rethink the entire framework by which infantry weapons were judged. They started by stripping the weapon down, laying each component on a table under bright inspection lamps. The stamped steel receiver drew immediate attention. Stamping was not new, but the degree to which the Germans relied on it for structural parts was surprising. The Americans noted how the Germans had embraced a ruthlessly practical approach: eliminate unnecessary machining, simplify shapes, reduce production hours, and accept a rugged appearance in exchange for speed and quantity. Where the M1 Garand required extensive machining and sophisticated metallurgy, the StG-44 embraced industrial efficiency. This was a weapon designed for a nation fighting with strained resources, yet trying to arm large numbers of troops in minimal time. But the stamp receiver was only the beginning. The gas system, long-stroke piston with a tilting bolt, captured attention. The engineers recognized that the design shared similarities with earlier Czech and German experiments, yet appeared refined, simplified, reliable under adverse conditions. They recorded that the bolt lockup system was robust and surprisingly tolerant of fouling or dirt, reflecting lessons painfully learned by German troops on the Eastern Front. Harsh winters, mud, and dust had shaped the rifle's development more than any theoretical doctrine. And then there was the cartridge. The 7.92 by 33 millimeters Kurz was unlike anything the Americans had in service. It delivered enough energy for effective fire out to several hundred meters, but produced far less recoil than a full-size rifle cartridge. During firing tests, American examiners repeatedly remarked on how quickly and accurately the weapon could be fired in semi-automatic mode. In fully automatic mode, while not as controllable as a modern assault rifle, it remained significantly steadier than any U.S. rifle or carbine chambered in a full-power round. The ordnance team fired the rifle in bursts, slow and rapid semi-automatic strings, and off-hand positions. What they found was unsettling. A German soldier with an StG-44 could put far more rounds on target in far less time than an American soldier with an M1 Garand. The Garand was accurate, tough, and reliable, but it was still a full-power rifle. The StG-44's recoil impulse allowed faster follow-up shots, and its design encouraged short, controlled bursts, something unthinkable with a battle rifle. In their notes, the Americans wrote that the StG-44 represented a new type of weapon, one that combined the firepower of a submachine gun with the range of a rifle. The significance of that conclusion was immense. The M1 and the Thompson were separate tools with separate purposes. The StG-44 merged the battlefield roles into one weapon, simplifying logistics, tactics, and training. The engineers realized they weren't just looking at an advanced rifle, they were looking at a paradigm shift. But beyond the mechanical analysis, there was a deeper layer to their evaluation, one rooted in human psychology and battlefield behavior. Throughout the war, American intelligence had collected countless interviews from both U.S. and Soviet soldiers who encountered German units armed with the new rifle. The Soviet accounts were especially revealing. Red Army reports from 1943 to 44 documented that German troops equipped with the early MP-43 prototypes displayed dramatically improved squad cohesion. One Soviet officer wrote that these German units were able to lay down a wall of fire without the usual pauses for reloading bolt rifles, noting the psychological pressure this created on advancing infantry. The weapon allowed German squads to project fear and intimidation through sheer volume of mid-range firepower. American analysts reviewing these documents understood that the StG-44 had been engineered not only to kill, but to influence perception. A rifle that could fire rapidly and accurately created the illusion of greater numbers. A squad armed with StG-44s could dominate an engagement before the enemy fully understood what they were facing. And in war, perception of strength often mattered as much as actual strength. Walking through their early battlefield reports, U.S. examiners found repeated references to the psychological effects of the weapon. Soldiers wrote about sustained bursts, unusual accuracy, and high-density fire coming from small German units. The Americans had expected submachine guns or machine guns to produce those patterns, not a rifle. When they learned that a German infantryman could deliver that level of firepower on the move, the implications were clear. This was the kind of weapon that could change infantry doctrine itself. Yet there was a paradox. Despite its revolutionary design, the StG-44 arrived too late, and in too few numbers to alter the war's outcome. American engineers studying the weapon kept this at the forefront of their evaluations. They were not fearing a gun that would turn the tide. They were analyzing a blueprint of the future, a glimpse into what warfare could look like if such ideas were fully developed. The engineers documented the rifle's weight, heavier than expected for its size. They noted its high bore line, which contributed to muzzle climb. They observed the complexity of production despite the use of stamped steel, and they carefully recorded its vulnerabilities. Sensitivity to extreme dirt if neglected, reliance on ammunition that Germany struggled to produce consistently, and the logistical challenges of issuing a new cartridge in the middle of a collapsing war. These were not flaws of engineering so much as flaws of timing. Germany had produced the right weapon at the wrong moment. Still, none of these practical limitations diminished the Americans' respect. They admired the forward-thinking concept. The way the rifle's design harmonized with real battlefield conditions. Every component, stock geometry, magazine curvature, heat shielding, reflected lessons learned in combat. This was not a laboratory experiment. It was a weapon shaped by survival, created because German infantry had demanded something that better matched the brutal reality they faced. As the ordnance team continued testing, they compared the StG-44 with the weapons in U.S. service. The M1 carbine was the closest functional counterpart, but its .30 carbine round lacked the power and penetration of the Kurz cartridge. The Thompson was devastating at close range, but ineffective beyond 100 meters. The Garand excelled at distance, but limited rapid fire with recoil and magazine capacity. None of them filled the middle ground with the versatility demonstrated by the StG-44. One examiner wrote that the rifle allowed the average soldier to fight at the distances where most combat actually occurs. That single sentence captured the essence of the weapon's importance. The Germans had not just created a new gun, they had created a new philosophy of infantry warfare. The interesting facts piled up as the Americans continued their research. For example, they learned that the StG-44 had been used early on in limited numbers during the 1943 battles around the Eastern Front. They learned that Hitler initially rejected the program, believing the weapon was unnecessary, only approving it after seeing frontline results. They learned that the German army had attempted to introduce new squad tactics built around the rifle's abilities, tactics that mirrored what modern militaries would later adopt. And on a purely technical level, the Americans discovered that the rifle sighting system was optimized for the ranges German soldiers now expected to fight at, 200 to 400 meters. This directly contradicted earlier doctrine that imagined infantry exchanging fire at distances above 500 meters. The StG-44 was a practical weapon synthesizing hard-won experience into metal and wood. Every test, every report, every comparison reinforced the same conclusion. The weapon was astonishingly modern, so modern that one American engineer reportedly remarked in private correspondence that it looked like something from the next war, not the current one. As their evaluation neared its end, the examiners assembled a technical summary noting both strengths and weaknesses, but the broader significance of the StG-44 extended far beyond their report. It influenced American research into intermediate cartridges. It shaped the thinking that would eventually lead to the U.S. M16 decades later, and it echoed across the world, influencing the designers of the Soviet AK-47, a weapon that would go on to define the latter half of the 20th century. Yet, at this stage in 1945, the Americans didn't know how far the influence would spread. All they knew was that they were looking at a weapon impossibly ahead of its time, one that forced them to confront an uncomfortable truth. Germany may have been losing the war, but in small arms innovation, they had taken a daring leap into the future. As the engineers completed their firing tests and began preparing their final assessments, they were left with one question hanging in the air, a question that would bridge history and psychology, technology and strategy. If this rifle had appeared 2 years earlier, in large numbers, how different would the battlefield have looked? The answer, they knew, would never be written in any official report. But the thought lingered, quietly unsettling, as they prepared to disassemble the rifle one last time. The final stage of the evaluation at Aberdeen Proving Ground was more than a technical exercise. By this point, American engineers were no longer simply analyzing a rifle. They were confronting the stark reality of innovation born under pressures of survival. Every component, every firing test, every observation reinforced a central truth. The Germans had produced the world's first true assault rifle, a weapon whose design was decades ahead of contemporary doctrine, and whose influence would ripple across future conflicts. As the firing range echoes faded and the rifle lay dismantled on the inspection table, the engineers examined its magazine design. The StG-44 used a curved, detachable 30-round magazine, a simple but revolutionary solution to one of the perennial problems of infantry combat: sustained fire. Earlier German rifles, like the Carabiner 98K, required frequent bolt cycling and had limited magazine capacity. Submachine guns could fire rapidly, but only at short range and with limited stopping power. The StG-44, by contrast, enabled a soldier to lay down continuous fire at distances where most firefights actually occurred, without exhausting ammunition immediately or losing control. This simple feature, its magazine and intermediate cartridge pairing, was where behavioral psychology and battlefield reality intersected. Soldiers firing the StG-44 were able to maintain a sense of dominance in combat. Volume of fire matters as much to morale as it does to lethality. When a German squad could deliver 3 or 4 times the number of hits in the same engagement, it created a perception of strength far beyond actual numbers. American troops facing such fire would experience hesitation, anxiety, even fear, not because the rifle was unstoppable, but because the psychological impact to control burst was overwhelming. This insight would resonate with U.S. military psychologists and tacticians. Weapons shape human behavior, and human behavior determines outcomes in chaotic engagements. The engineers also turned their attention to the gas-operated tilting bolt mechanism. It was simple enough to maintain, yet robust enough to withstand prolonged use under harsh conditions. Reports from captured German rifles demonstrated they performed reliably in mud, snow, and extreme temperatures, a testament to the rigorous testing the Germans had imposed during development. In the notes, the Americans wrote that the StG-44 represented a deliberate trade-off: simplicity in design and manufacturing, paired with sufficient durability and performance. It was efficiency under pressure, and it worked precisely because it addressed both human limitations and operational realities. The rifle's ergonomics further emphasized its psychological advantage. The rifle's stock geometry, weight distribution, and recoil characteristics allowed soldiers to fire from the prone, crouched, or standing positions with unprecedented ease. Soldiers could adjust quickly between single-shot precision and short, controlled bursts, maximizing their adaptability in unpredictable combat. These characteristics were crucial on the Eastern Front, where German infantry faced a wide range of engagement types, from open plains to dense forests and bombed-out urban environments. The StG-44's design reflected an understanding that combat is dynamic, and that soldiers need a weapon that adapts to the environment, not the other way around. Another fascinating revelation for American analysts was the StG-44's influence on squad tactics. German infantry manuals of late 1944 and 1945 explicitly outlined tactics optimized for weapon. Small squads could concentrate fire, shift targets quickly, and maintain suppressive fire without depending on heavy machine guns. This was a clear departure from previous doctrine, where bolt-action rifles dominated squad firepower and machine guns dictated maneuver. Here, innovation at the weapons level directly shaped human behavior on the battlefield. Every burst from the StG-44 was not just a shot, but a calculated psychological tool designed to dominate space and force enemy movement or hesitation. Yet despite these technological and tactical breakthroughs, the American engineers understood the limits imposed by history. Germany was losing the war. The StG-44 arrived too late, produced in insufficient numbers, and distributed unevenly among frontline units. While it could have influenced smaller engagements or defensive operations, the sheer scale of Allied forces, air superiority, and logistical domination meant that no rifle, however revolutionary, could reverse the trajectory of 1945. In private notes, examiners reflected that the rifle was a glimpse of potential unfulfilled, a vision of what might have been if innovation had arrived earlier or in greater quantity. The post-war analysis of the StG-44 also illuminated its profound legacy. American engineers, after completing the tests and compiling exhaustive reports, stored detailed diagrams, firing data, and photographic documentation. These findings would influence small arms development for decades. The principles embedded in the StG-44, the use of intermediate cartridges, detachable magazines, selective-fire capability, and ergonomic design optimized for real-world combat, directly informed post-war weapons like the US M16 and the Soviet AK-47. Historians and engineers alike later recognized that the StG-44 was not just a German weapon, but the blueprint for modern assault rifles worldwide. Even more telling was the psychological impression left on the men who handled it. In technical reports, American evaluators repeatedly described a sense of futuristic design and unanticipated capability. There was a quiet acknowledgement that the rifle's effectiveness extended beyond raw ballistics. It shaped confidence, decision-making, and perception on the battlefield. Soldiers were empowered not merely by hitting a target, but by feeling in command of the engagement. And this is precisely why the StG-44's legacy is as much about behavioral impact as technical innovation. One anecdote frequently cited in ordnance reports involved a captured rifle returned from forward testing. The American officer overseeing the test range reportedly remarked, "It is incredible to hold a rifle that feels familiar, yet is unlike anything we have ever seen in operation." This statement captures the essence of the StG-44, a hybrid between the familiar and the revolutionary, a bridge from the bolt-action era into the modern age of infantry warfare. Yet the rifle was not flawless. The Americans observed that the StG-44's production quality, while impressive under wartime constraints, suffered from inconsistencies. Some rifles exhibited imperfect finishes, slightly warped stamp parts, or variable magazine reliability. These were not design flaws, but the consequences of a nation under siege, producing at speed in limited factories with stretched supply lines. The engineers appreciated the ingenuity that overcame these limitations. Even imperfect rifles were reliable enough to be deployed effectively, a testament to practical, field-driven engineering. As the evaluation concluded, the ordnance team synthesized a series of conclusions. First, the StG-44 was a weapon optimized for realities amid 20th century infantry combat, close, chaotic, and psychologically taxing. Second, it was an early but fully functional embodiment of the assault rifle concept, demonstrating that a single weapon could combine rapid-fire capability, effective range, and ergonomics in a portable, manageable form. Third, it served as a stark example of how necessity, operational feedback, and human factors could drive innovation faster than doctrine or bureaucracy might allow. And finally, it left a lasting impression on American engineers that would influence weapons design philosophy for decades. Sometimes, the future arrives before we are ready for it, forged not in laboratories but in the crucible of war. The human dimension of the StG-44 story is equally compelling. Soldiers wielding it experience tangible advantages, increased survival probability, higher engagement effectiveness, and the confidence to execute complex squad tactics. For enemies encountering it, the psychological impact could be decisive. Even a brief engagement with a small group of StG-44 equipped troops could induce hesitation, disrupt coordination, and amplify the perceived threat. In the calculus of war, this effect was invaluable. The Americans who studied the weapon recognized that its battlefield significance extended beyond bullets per minute. It was a tool that shaped human perception, courage, and fear. And yet, the most profound lesson may be this. The StG-44 demonstrated that the evolution of warfare is inseparable from a human mind. Weapons are not just tools. They are extensions of human intent, instruments of psychology, and embodiments of adaptation. The Germans, in desperation, had created a rifle that leveraged both engineering and behavior to maximum effect. Its existence challenged assumptions about timing, innovation, and the relationship between design and combat reality. By the time the American tests were concluded, the engineers and historians reviewing results were left with an undeniable truth. The StG-44 was not merely a weapon of World War II. It was a weapon ahead of its time. It provided a blueprint for the modern battlefield, reshaped expectations of infantry firepower, and demonstrated the intertwined nature of technology, and human behavior under the pressures of survival. The rifle's capture, testing, and analysis represented a rare opportunity to witness the future of warfare forged in real time before it became common knowledge around the world. As the engineers boxed the StG-44 components for storage and archival, there was a palpable sense of closure and awe. They had dissected, measured, and understood every facet of the weapon, yet the larger story remained: a weapon conceived out of necessity, optimized for human use, and delivered into a conflict that would not allow it to reach its full potential. It was a moment in history where engineering, psychology, and the chaos of war converged, leaving an indelible mark on military thought. And so the story concludes, not with a battlefield victory, nor with a dramatic single-handed triumph, but with understanding that innovation often arises from the edge of desperation, understanding that technology and human behavior are inseparable in the theater of war, understanding that the StG-44, for all its later rival in limited numbers, was a seed planted in the soil of World War II that would grow into the modern assault rifle, shaping conflicts for generations to come. In the end, American engineers who examined the StG-44 could only marvel at what they held. They had seen a weapon that redefined expectations, challenged assumptions, and illuminated the future. And though its time in history was brief, its influence was permanent, a reminder that the intersection of human ingenuity, battlefield necessity, and psychological insight can produce innovations that the world is not yet ready to see.